Hello everyone, welcome to Maths and Science Intervention Club. My name is Mr. Nkuna. Today we're going to be doing grade 12 mathematics paper 1. We're going to start with our first question, which is question 1. So the first question, we are required to solve for x. So let us write our first question. We have 1.1.1. We have 2x, 3x plus 4. It is equal to 0. So here we are required to solve for x. What should x be, so that when we substitute that x value wherever I seek x, the left hand side and the right hand side will be equal. So already here we have a 0 as our number on our right hand side, meaning we can simply split our terms. Therefore we're going to have 2x, it is equals to 0, or 3x plus 4, it is equals to 0. Now 2 and x, they are multiplying. I'm going to do the inverse operation of multiplication, which is to divide both sides by 2, because whatever that I do on the left, I should also do on the right. Therefore our x value should be equals to 0, or on the other side, I can see that this particular 4, it is positive, right? And here we have 3x plus 4. These are unlike terms. There's nothing that I can do over there, but rather I'm going to take this particular 4x to the other side, meaning I'm going to have 3x. It is equals to negative 4. 3 and x, they are multiplying. Therefore, I'm going to divide both sides by 3, so that I'll be left with the value of x. Therefore x, it is equal to negative 4 over 3, meaning our x value should be 0, or our x value should be negative 4 over 3, so that the left hand side and the right hand side will be equal when I substitute. Now let us do 1.1.2. 1.1.2, we have 2x squared minus 4x, it is equals to negative 1. So here we can already see that they are saying correct to 2 decimal place. So whenever you see this statement, you should know that you have to use the quadratic formula. So the quadratic formula, it is given as so here we are looking for x. Therefore I'm going to say x, it is equals to negative b plus minus on a square root b squared minus 4ac, all divided by 2a. So now this particular format, I can see that it is this particular question, it is not written on a standard form, meaning I have to rewrite my question on a standard form. Meaning for me to rewrite that, obviously the value of a should be x to the power of 2, meaning I'm going to have 2x squared minus 4x, it is equal plus 1, it is equals to 0. Now whenever it is like this, I can now see my a, my b, and my c. Therefore I can now start and substitute. I'm going to have x, it is equals to negative. What is our b value? It is already negative 4 plus minus on a square root b squared. Our b is negative 4 squared minus 4. What is the value of a? It is 2. What is the value of c? It is positive 1, all divided by 2a, right? So our 2a, it is also 2. So the value that the coefficient here, it is our a value, the coefficient there, it is our b value, and the constant over there, it is our c value. So you simply substitute your a being 2, your b being negative 4, and your c being positive 1. Now at this point we are going to have x, it is equal to, no need to stress yourself, just plug everything that is here on a calculator. You're gonna start with the sign being positive, then you start with the sign being negative, because you cannot put plus or minus at the same time. We're gonna have our x value, so this is we're gonna have 4. We're going to have 4 we're gonna have 4 plus or minus, we're going to have 8 here, and 4. Therefore x value is going, then after you're going to round your answer to 2 decimal place, because here they said correct to 2 decimal place, right? Therefore we're going to have our x value being 1,71, or the x value being x, it is equals to 0,29 when we round off to 2 decimal place, right? Let us do question 1.1.3. Now in question 1.1.3, we are having inequalities, right? So we have x minus 2 all squared, it is greater or equals to positive 1. Now if we have such an inequality, the first thing that we have to do, we have x minus 2 all to the power of 2, it is greater or equals to 1. So the first thing that we have to do in this particular format, it is to expand. It is to expand what we have. So we're going to have x minus 2 is greater or is equals to 1. Now at this particular format, we can say critical values. Instead of putting greater or equals to 1, we can simply put x squared, x minus 2, it is equals to 1. Therefore we're going to have x minus 2, it is equals to positive 1. So we replace that greater or equals to with what? With an equal sign here. Therefore now I'm going to expand. You remember the FOIL method, how we expand. This is how we expand. Therefore it's going to be x times x, which is going to be x squared. Then we're going to have x multiplied by negative 2, which is negative 2x, negative 2 multiplied by x, which is negative 2x, then negative 2 multiplied by negative 2, which is going to give us positive 4. Now this particular one, it is positive on the right hand side, therefore it's going to be negative on the left hand side, minus 1, it is equals to 0. Now after having such, we are going to see that this particular negative 2 and this negative 2x, they are like terms, right? Because they are having the same variable raised to the same exponent. Therefore it means I'm going to have x squared minus 4x plus 3, it is equals to 0, because 4 minus 1, it is 3. Now after having such, we are going to see that we are required to now do what? To factorize. So for us to factorize, it's either use a quadratic formula or we can use this method. Look for two numbers such that when you multiply, they give you positive 3. But then when you add these two numbers, they give us negative 4. So we know that 3 times 1 will give us 3, and also negative 3 multiplied by negative 1 will also give us positive 3. But then if I were to change this particular sign here, then I put plus, right? It is going to give us 4. And if I change this sign, then I put plus here, it is going to give us negative 4. Meaning these are the numbers that I'm looking for, negative 3 and negative 1. So now it means two numbers, when I multiply, they give me positive 3. But then when I add those two numbers, they give me negative 4. It is negative 3 and negative 1. Meaning I'm going to have x minus 3, x minus 1, it is equals to 0. At this point, we are going to have x minus 3, x minus 1, it is equals to 0. It means x minus 3, it is equals to 0, or x minus 1, it is equal to 0. Now I'm going to take that negative 3 to the other side, take this particular negative 1 to the other side, right? Me doing so, I'll have x, it is equals to 3, or x, it is equals to 1. But then here we were not solving for x, right? But then it was an inequality. Now when we have an inequality, our original sign, it was greater or equals to. So now we are going to look at these numbers here. We have x being equals to 3, and we have x being equals to 1. So the number that is big between 3 and 1, it is going to take the original sign here, meaning we're going to have x, it is greater or equals to 3, and we're going to have x, which is less or equals to positive 1. So the bigger number between these two, it is the one that is going to take the original sign that we had, and our original sign, it was this sign that we have over here. Now after doing that, we are going to check if this particular I think that's it. Or we can check if this particular numbers, they satisfy the condition. But then the number that is big between these two, it is the one that is going to take the original sign. Now let us go to 1.2. So we are going to do question 1.2. Now 1.2, we have 1.2.1, 1.2.1. So we are given x minus 2, it is equal to 4 minus x. So 1.2.1, it says without solving for x, show that the solution lies between the interval of x being greater or equals to 2, or x is less or equals to 4. So here we are not required to solve for x, but rather we are required to show that the solution for x, it is found between x being greater than positive 2 and x being greater or equals to positive 4. So if we were to draw a number line, we have our 4 here and we have our 2 here. So greater or equals to, it means this is part of the solution. That is why we're going to have our dot, which is shaded, right? So numbers that are greater than positive 2 but then less than positive 4, meaning our solution should be found here in this according to this particular statement, meaning our solution for this to be true, they should be found in this particular number line. Let us see. So now when we look here, we have x minus 2, which is inside a what? A square root. Now we already know that numbers that are inside the square root, they should always be positive. Now we could, if we have negative n inside the square root, this one is going to give us a what? An error, right? Because inside the square root we cannot have a negative number. It means whatever that is here, this particular x minus 2, it should be greater or equals to 0, so that this particular statement becomes true. Right, because inside the square root, I cannot have a number that is less than 0. And also, if that is the statement, it means 4 minus x, it should also be greater or equals to 0, because of this particular statement that we have over here. Now, after doing that, now I am going to solve for x, but then without solving for x specifically, we're going to see that we are going to have x, this particular negative 2, we're going to take it to the other side. Therefore, we have x. Here we're going to have a positive 2. X, it is greater or equals to positive 2. So this particular negative 2 is going to go that side, and it's going to become what? It is going to become positive. And also here, we're going to have 4 minus x, it is greater or equals to 0. Now here, I'm going to take this 4 to the other side, right? Therefore, I have negative x, it is greater or equals to negative 4. But then I'm looking for x, not negative x, meaning I'm going to divide both sides by negative 1, negative 1. Therefore, x, this sign, if you divide by a negative number, this sign will change. Therefore, if it changes, we're going to have something like this. Then we're going to have a 4 here. Now, can you see that this is the number line that we have from the first place, whereby x, it is greater or equals to negative 2, but then x is less or equals to negative 2. So here we do not solve, but then we used delta to say that for us to have real numbers, the number that is inside the square root should always be positive. Now let us do 1.2.1. So on question 1.2.1, we are now then required to solve for the x value. So for us to solve for the x value, we are going to have the square root 1.2.1. We are going to have x minus 2, it is equals to 4 minus x. Now we are required to solve for x. Now since we have a square root, so for us to remove this particular square root means we are going to use the inverse operation of a square root, which is a square. Meaning here I have to apply a square on both sides. Now if I apply a square here on the left hand side, I'm going to have x minus 2, it is equal to. And on the right hand side, obviously, we're going to have, we're going to expand. Therefore, we're going to have 4 minus x. 4 minus x, right? Therefore, I'm going to have x minus 2, it is equals to 4 times 4. You remember the 4 method, this particular method, the one of expanding. Now, when we do that, we're going to have 4 times 4, which is 16. 4 times negative x, which is negative 4x. Negative x multiplied by 4, which is negative 4x. Then x, negative x multiplied by negative x, which is going to be positive x squared, right? Now, these two terms, they are like terms because they are having the same variable raised to the same exponent, meaning I'm going to have x minus 2, it is equals to 16 minus 8x plus x squared, right? Now, after doing this, I have a right to take all the terms here to the right-hand side so that I can keep my x squared as a positive number. Now, me doing so, I'm going to have 0, it is equal to 0, it is equal to 16 minus 8x minus x plus x squared plus 2, right? Now this particular 16 and this particular 2, they are like terms, therefore I'm going to have 0 it is equal to x squared. I'm going to start with the biggest exponent of x, which is x squared minus 9x. Then I'm going to have 16 plus 2, which is going to be plus 18. Now, after doing this, I am now required to solve for x. So for me to solve for x, it's either I use a quadratic formula or I look for two numbers such that when I multiply those two numbers, they are going to give me positive 18, but then when I add those two numbers, they are going to give me negative 9. So I know that negative 3 multiplied by negative 6, it is what? Positive 18. And if I remove this particular negative sign, then I substitute a positive sign there. It's going to be negative 3 plus negative 6, which is negative 9, meaning those numbers, it is negative 3 and negative 6. Therefore I'm going to have 0 it is equal to x minus 3 x minus 9, right? Because negative 3 times negative 9, it is negative 6, I mean it is positive 18, and negative 3 plus negative 6, it is negative 9. Therefore after doing this, I'll have x minus 3 it is equals to 0, or x minus 6 it is equals to 0. I'm going to have x it is equals to 3, or x it is equal to 6. Now since here it was in this particular form, this one, we have to confirm. Now for us to confirm, wherever you see x, substitute positive 3, and wherever you see x, substitute positive 6, and see if the left hand side and the right hand side are going to be equal under that particular format. So I'm going to have the square root of x minus 2 it is equals to 4 minus x. Now wherever you see x, substitute these terms. Now let us start with 3. If I substitute 3 here, it means even here where there's x, I have to substitute 3. Now, if I substitute 3 on the left-hand side, it's going to be the square root of what is 3 minus 2, it is 1. And what is 4 minus 3, it is 1. What is the square root of 1, it is 1. And here, we also have a 1. Therefore, the left-hand side and the right-hand side are equal if x it is equals to 3. Now we're going to do the very same thing that we did before. Wherever you see x, we substitute what? The value of x. So here I'm going to substitute 6, and even here I'm going to substitute 6. Now after substituting 6 is going to be, we are going to have what is 6 minus 2, we're going to have a 4 here, and what is 4 minus 6, we're going to have a negative 2. Now what is the square root of this particular 4? We're going to have 2 it is equals to negative 2, but then we know that 2 and negative 2, they are not equal. Therefore x cannot be what? X cannot be positive 6, because if I substitute the value of x being 6, the left hand side and the right hand side, they are not equal. Therefore x should be x it is not equals to positive 6. Now we are now going to do simultaneous equation. Now for us to do simultaneous equation, it means we are solving for x and y at the same time. So now solving for x and y at the same time, it means we are going to involve equation number 3. So 1.3, we have 3x plus y it is equal to 2, that is equation 1, and we have y squared it is equal to 2x squared minus 1, that is equation 2. Now let us, between equation 1 and equation 2, we are going to make x or y the subject of the formula. So in equation y, we can already see that the coefficient of y it is 1. Therefore we're going to use equation 1 to form equation 3. Therefore for me to form equation 3, we are going to have y it is equal to 2 minus 3x, which is going to be equals to equation 3. Now this particular equation 3 comes from equation 1, right? Therefore it means we're going to substitute equation 3 into equation 2 to solve for x and y. Now here I took this particular negative 3x to the other side. That is why it became what? It became negative 3x. Therefore on our equation 2, we had y squared it is equal to 2x squared minus 1. Now we already know what the value of y is, right? It is 2 minus 3x, meaning wherever I see y, I have a right to substitute 2 minus 3x. So me doing so, I'm going to have 2 minus 3x all squared, it is equals to 2x squared minus 1, right? Now here we have 2, means we are going to expand. Therefore, I'm going to have 2 minus 3x, 2 minus 3x, it is equals to 2x squared minus 1, right? Now, after doing this, the FOIL method, the method that we were doing before, the FOIL method, the one of what? Of expanding. Now it's going to be 2 multiplied by 2, which is going to become 4. 2 multiplied by negative 3x, which is going to become negative 6x. Negative 3x multiplied by positive 2, negative 6x again. The negative 3 multiplied by negative 3 is going to be positive 9x squared. And this side, we're going to have 2x squared minus 1. Right. Now, after doing that, we are going to look for our like terms. I'm going to see that this particular negative 6x and negative 6x, they are like terms, meaning I'm going to have 4 minus 12x plus 9x squared. Now, all these terms here, let me just take them to the left-hand side, meaning I'm going to have minus 2x squared plus 1, it is equals to 0. Now, this negative 2x squared and this particular 9x squared, they are like terms. Now, after doing that, I'm going to see that 9x squared minus 2x squared, it is equals to 7x squared. Now, I'm going to start with the bigger exponent of x. Therefore, I'll have 7x squared, 7x squared minus 12x. Here it is a plus 1, therefore it's going to become 4 plus 1, which is going to be equals to 5, plus 5, it is equals to 0. Now, after having such, I'm going to see that I want to solve for x, right? Now, for me to solve for x, it's either I use a quadratic formula at this stage, or I'm going to expand. I'm going to factorize. So for me to factorize, I'm going to have 7x minus 5, and I'm going to have x minus 1, it is equals to 0. Now, because if I were to expand these, I'm going to have 7x squared, and this is what I'm going to have, because if I were to expand, it's going to be 7x squared minus 7x minus 5x, which is going to give us the negative 12x that is already here. Then it's going to be negative 5 multiplied by negative 1, which is going to give us the positive 5 that is already here. Now, after doing that, I'm going to have 7x minus 5, it is equals to 0, or x minus 1, it is equals to 0. I'm looking for the value of x, right? Therefore, it means I'm going to have 7x, it is equal to positive 5, or x, it is equal to positive 1. So here, it means I'm required to divide both sides by 7. Divide by 7, divide by 7. Therefore, x, it is equals to 5 over 7. Now, I only got the value of x, meaning I should also find the value of y. So let us take these numbers that are here. X, it is equals to 5 over 7, or x, it is equal to positive 1. Meaning, let us go back to equation number 3. Wherever I see x, I have to substitute the value of x, this one, so that I find the value of y. Equation number 3 was given as y, it is equals to 2 minus 3x, right? Wherever I see x, substitute the 1, and wherever I see x, substitute this particular 5 over 7, so that we can find the value of y. So let us start with the easier one, which is going to have y, it is equals to 2. Y, it is equals to 2 minus 3. We're going to substitute 1 here. Therefore, y is going to be equals to 2 minus 3. Therefore, y becomes negative 1, because 2 minus 3, it is equals to negative 1. Then now, we're going to use the very same method, but then whenever I see x, I have to substitute this particular 5 over 7. We're going to have y, it is equals to 2 minus 3. Wherever I see x, substitute 5 over 7. Therefore, y, it is equals to, let us use a calculator. What is 2 minus 3, open bracket, 5 over 7? The value of y becomes negative 1 over 7. Now we have gotten our values of x and y simultaneously. Now let us go into the last question, which is question 1.4. So question 1.4, it is usually the questions whereby we are leaving our answer, or here it's a proof. We are required to prove if we are given 1.4. So 1.4, we are given that r plus 2s, it is equals to a, and r minus 2s it is equals to b. So we are required to prove,